store and process data into useful information. The IT industry refers to the entire scope of all the jobs and resources that are related to computing technologies within society. And there are a lot of different types of jobs in this field, from network engineers who ensure computers can communicate with each other, to hardware technicians who replace their components, to desktop support personnel who make sure that end users can use their software properly. But IT isn't just about building computers and using the internet, it's really about people. That's the heart and soul of IT support. What good is technology or information if people can't use technology or make sense of information? IT helps people solve meaningful problems by using technology, which is why we see its influences in education, medicine, journalism, construction, transportation, entertainment, or really any industry on the planet. IT is about changing the world through the ways we collaborate, share, and create together. IT has become such a vital tool in modern society that people and organizations don't have access to IT or at a disadvantage. IT skills are becoming necessary for daily living, finding a job, getting an education, looking for health information. Maybe you're from a community where there wasn't any internet, or you couldn't afford a super fast computer, and had to use one at your school or library instead. There are many social and economic reasons why some people have digital literacy skills and other people do not. This growing skills gap is known as the digital divide. People without digital literacy skills are falling behind. But people like you are the real solution to bridging that digital divide. Overcoming the digital divide not only involves confronting and understanding the combination of socioeconomic factors that shape our experience, but also helping others confront and understand those experiences. By getting into IT, you'll help serve those in your communities, organizations, and maybe even inspire a new generation of IT pioneers. When I think about solving the digital divide, I can't help but think of all the opportunities and breakthroughs that folks from diverse backgrounds and perspectives in the industry can bring. So what's the day-to-day work of someone in IT support like? Well, it varies a ton based on whether you're doing in-person or remote support, and at a small business or a large enterprise company. There's really no such thing as day-to-day work, since the puzzles and challenges are always new and interesting. But in general, an IT support specialist makes sure that an organization's technological equipment is running smoothly. This includes managing, installing, maintaining, troubleshooting, and configuring office and computing equipment. This program is designed to prepare you for an entry-level role in IT help desk support. You'll learn how to set up a user's desktop or workstation, how to install the computer applications that people use the most. You'll learn how to fix a problem or troubleshoot when something goes wrong, and how to put practices in place to prevent similar problems from happening again. Not only will you learn the technical aspects of troubleshooting a problem, you'll also learn how to communicate with users in order to test the system. We'll also show you how to set up a network from scratch to connect to the internet, teach you a thing or two about automation and scripting, and teach you about how to implement security to make sure your systems are safe from hackers and other risks. For me, my favorite part of IT support is the problem-solving aspect. I love to exercise my creativity to spin up a solution to a user's issue. Being an IT generalist also gave me the flexibility to learn and practice so many different skills and eventually determine where I'm going to focus my career. Plus, when things go wrong or you fail at something in IT, you can take the feedback from those mistakes and be better equipped to tackle them the next time around. Using failure as a feedback is an important skill both in IT and in life. For me, that's why I was so attracted to the IT field. I love the process of problem solving and constantly stretching myself to learn and grow. There's also never been more opportunity to get into the IT industry than now. Not only is the field of IT incredibly diverse, but job prospects are also booming. It's projected that IT jobs in the US alone will grow 12% in the next decade. That's higher than the average for all other occupations. So what does this all mean? There are thousands of companies around the world searching for IT professionals like you. So the main gist is that IT is totally awesome and full of opportunity, and we're so excited that you're here. So let's dive right in. On July 20th, 1969, one of the most phenomenal events made its way into the history books. When the Apollo 11 completed its historic mission to the moon. While those brilliant minds helped to make sure that the Eagle had landed, computers also played a significant role. The guidance system that navigated spacecraft was one of the earliest forms of modern computing. That same computer, the one that helped America's lunar dreams become reality, took the space of an entire room and had 1/10,000 the computing power of the thing that almost everyone can carry in your pockets today, the smartphone. Computer hardware and software have had such a dramatic evolution that what was once only used to power rockets now shapes the entire way our world functions. Think about your day. As you grab a snack, turn on your TV, take a drive in your car, computers roll along for the ride. Literally, computers are everywhere. So here's the rundown. By the end of this course, you'll understand how computers work and get a grasp of the building blocks of IT. We're going to cover the basics of how computer hardware performs calculations, and we're going to actually build a computer from the ground up. We'll look at how operating systems control and interact with hardware. We'll take a look at the internet and get a better understanding of how computers talk to each other. We'll also spend time learning about how applications and programs tie all of this together and let humans interact with these systems. Finally, we'll cover important lessons on problem solving with computers and cover the communication skills that are so critical when interacting with others in IT. Whether you're looking for a job in the IT industry or you just want to learn how your laptop connects to the internet, understanding how computers work at every level may help you in your day-to-day life and in the workplace. But first, let's take a step way back to where it all began, even before the Apollo 11 mission touchdown, so you can understand how and why we use computers today.
Hi there, I'm Amanda from Grow with Google. We're the team behind the Google Career Certificate, and we're thrilled you've decided to pursue yours in IT support. Experts here at Google created this program to help you develop skills that prepare you for jobs. Once you complete your certificate, you'll join a community of over 1 million graduates who are launching their new careers, and you'll instantly unlock resources to help you launch yours. This includes an industry-recognized credential from Google that can be added to your resume and professional profiles like LinkedIn. Additionally, you'll receive a discount to your CompTIA's A+ certification, which further demonstrates your IT support skills and helps you stand out to employers. We're also here to support you along the way as you navigate your job search. We know there's a lot involved in finding a new job, so included at the end of the certificate program, you'll find a course that shows you specific ways to use AI to streamline your search. You'll identify your transferable skills, update your resume for different roles, and practice and grade, all with the help of AI. Plus, for learners in the United States, you can sign up for one-on-one career coaching and access thousands of job listings through Career School at no cost to you. These valuable resources are exclusively for Google Career Certificate graduates. Starting strong is the best way to ensure you complete the program. You can access these resources. Here are a few of our top tips to get you to the finish line. First, stay on top of the deadlines, especially in these early weeks. Learners who do this are almost twice as likely to finish their certificate. Second, jump into the learner community right away. This is a great place to get advice and connect with other learners like you. Having this community as a resource to turn to when it's done significantly boosts your chances of success. And finally, don't get discouraged if you face challenges. It happens. Remember what brought you here, take advantage of the support available to you, and know that with persistence, you've got this. For the latest from Google on career advice, ideas on how to use AI, and notifications about new courses, subscribe to our newsletter at grow.google/updates. We wish you the very best as you embark on this exciting journey, and look forward to supporting you as you earn your Google Career Certificate. Welcome to Course 1, Technical Support Fundamentals. In the first course of this certificate, you will be introduced to information technology, or IT. You'll learn about the facets of IT, like technology, computer hardware, computer software, troubleshooting, the internet, and customer service. As a learner, you can choose to complete one or multiple courses in the Google IT Support Certificate program. However, to obtain the certificate, you must complete all courses in the program and submit all graded assignments. This This reading describes what is required to obtain a certificate and best practices for you to have a good learning experience. Course completion to obtain a certificate. To receive your official Google IT support certificate, you must pass all graded assignments in all 6 courses of the certificate program. Each graded assignment is part of the cumulative grading score for the course, and the passing grade for each course is 80%. And one of the following: pay the course certificate fee, be approved for Coursera financial aid, or complete the certificate through an educational institution, employer, or agency that's sponsoring your participation. Program overview. The entire program has 6 courses: technical support fundamentals, bits and bytes of computer networking, operating systems, and you, becoming a power user, system administration, and IT infrastructure services, IT security, defense against the digital dark arts, accelerate your job search with AI. Healthy habits for course completion. Here is a list of best practices that will help you successfully complete the courses in the program. Plan your time. Setting regular study times and following them each week can help you make learning a part of your routine. Use a calendar or timetable to create a schedule and list what you plan to do each day in order to set achievable goals. Find space that allows you to focus on reviewing videos and readings and complete course activities. Work at your own pace. Everyone learns differently, so this program has been designed to let you work at your own pace. Although your personalized deadlines start when you enroll, feel free to progress through the program at the speed that works best for you. There is no penalty for late assignments. To earn your certificate, all you have to do is complete all of the work. Note, if you need more time to complete a section of the course, you can simply extend your deadlines. When your session ends, select Switch Schedule to begin a new course schedule. You won't lose any course progress, and you can reset deadlines as many times as you want. Be curious. If you find an idea that gets you excited, act on it. Enrich your learning experience with Gemini's guided learning feature. It acts as your personal learning assistant, helping you ask insightful questions, find more details online, and explore interesting topics. The steps you take to support your learning will advance your knowledge, create more opportunities for you in this high-growth field, and help you qualify for jobs. Take notes. Notes will help you remember information in the future, especially as you're preparing to enter a new job field. In addition, taking notes is an effective way to make connections between topics and gain a better understanding of those topics. Build your career identity. Your career identity is the unique value you bring to the workforce. Watch this video to learn about the key components of career identity and write your own career identity statement. Discovering and defining your own career identity makes you better equipped to choose a career path that aligns with your strengths, values, and goals, and is more effective in your chosen profession. Connect with other learners. If you have a question, chances are you're not alone. Reach out in the discussion forum to ask for help from other learners in this program. You can also visit Coursera's private Google IT support community to expand your network, discuss career journeys, and share experiences. Check out the Quick Start Guide. Update your profile. Consider updating your profile on Coursera to include your photo, career goals, and more. When other learners find you in the discussion forums, they can click on your name to access your profile and get to know you better. Documents, spreadsheets, presentations, and labs for course activities. To complete certain activities in the program, you will need to use digital documents, spreadsheets, presentations, and/or labs. IT support professionals use these software tools to collaborate with their teams and organizations. If you need more information about using a particular tool, refer to these resources: Microsoft Word, Help in Learning, Microsoft Support page for Word, Google Docs, Help Center page for Google Docs, Microsoft Excel, Help in Learning, Microsoft Support page for Excel, Google Sheets, Help Center page for Google Sheets, Microsoft PowerPoint, Help in Learning, Microsoft Support page for PowerPoint, How to use Google Slides, Help Center page for Google Slides, Common Problems with Labs, Troubleshooting help for quick labs activities, weekly, course, and certificate glossaries. This program covers a lot of terms and concepts, some of which you may already know, and some of which may be unfamiliar to you. To review terms and help you prepare for graded quizzes, refer to the following glossaries. Weekly glossaries. At the end of each week's content, you can review a glossary of terms from that week. The weekly glossaries are not downloadable. However, all of the terms and definitions are included in the course and certificate glossaries, which are downloadable. Course glossaries. At the end of each course, you can access and download a glossary that covers all of the terms in that course. Certificate glossary. The certificate glossary includes all of the terms in the entire certificate program and is a helpful resource that you can reference throughout the program or at any time in the future. You can access and download the certificate glossaries and save them on your computer. You can always find the course and certificate glossaries using the Course's Resources tab. To access the IT Support Certificate Glossary, click the following link and select Use Template. Link to the glossary, IT Support Certificate Glossary. Or if you don't have a Google account, you can download the glossary directly from the following attachment: certificateglossary.docx. Course feedback. Providing feedback on videos, readings, and other materials is easy. With the resource open in your browser, locate the thumbs up and thumbs down symbols. Click thumbs up for materials that are helpful. Click thumbs down for materials that are not helpful. If you want to flag a specific issue with an item, click the flag icon, select the category, and enter an explanation in the text box. This feedback goes to the course development team and isn't visible to other learners. All
अरे ना दर्द है आ बची ना हम तेरे आ बची ना में बची गई तेरी आदत है कि खुशबानी तेरे बिना ना मुझ में नहीं आदत है गलती तेरी है जो मैं रोता हूँ तू ले तू करे रंग साथ जियल गए ओ कब
When you hear the word computer, maybe you think of something like a beefy gaming desktop with flashing lights, or maybe you think of a slim and sleek laptop. These fancy devices aren't what people had in mind when computers were first created. To put it simply, a computer is a device that stores and processes data by performing calculations. Before we had actual computer devices, the term computer was used to refer to someone who actually did the calculation. You're probably thinking that's crazy talk. My computer lets me check social media, browse the internet, design graphics. How can it possibly just perform calculations? Well, friends, in this course, we'll be learning how computer calculations are baked into applications, social media, games, etc., all the things that you use every day. But to kick things off, we'll learn about the journey computers took from the earliest known forms of computing into the devices that you know and love today. In the world of technology, and if I'm getting really philosophical in life, it's important to know where we've been in order to understand where we are and where we're going. Historical context can help you understand why things work the way they do today. Have you ever wondered why the alphabet is laid out in order on your keyboard? The keyboard layout that most of the world uses today is the QWERTY layout, distinguished by the Q, W, E, R, T, and Y keys, and the top row of the keyboard. The most common letters that you type are found on the home, where your fingers hit the most, but why? There are many stories that lend answer this question. Some say it was developed to slow down typists so they would jam old mechanical typewriters. Others claim it was meant to resolve problems for telegraph operators. One thing is for sure, the keyboard layout that millions of people use today isn't the most effective one. Different keyboard layouts have even been created to try and make typing more efficient. Now that we're starting to live in a mobile-centric world with our smartphones, the landscape for keyboards may change completely. Typing fingers across. In the technology industry, having a little context can go a long way to making sense of the concepts you'll encounter. By the end of this lesson, you'll be able to identify some of the most major advances in the early history of computers. Do you know what an abacus is? It looks like a wooden toy that a child would play with. It was actually one of the earliest known computers. It was invented in 500 BC to count large numbers. While we have calculators like the old reliable TI-89s or the ones in our computers, the abacus is actually still used today. Over the centuries, humans built more advanced counting tools, but they still require a human to manually perform the calculations. The first major step forward was the invention of the mechanical calculator in the 17th century by Blaise Pascal. This device used a series of gears and levers to perform calculations for the user automatically. While it was limited to addition, subtraction, multiplication, and division for pretty small numbers, it paved the way for more complex machines. The fundamental operations of the mechanical calculator were later applied to the textile industry. Before we had streamlined manufacturing, looms were used to weave yarn into fabric. If you wanted to design patterns on your fabric, it took an incredible amount of manual. In the 1800s, a man by the name of Joseph Picard invented a programmable loom. These looms took a sequence of cards with holes in them. When the loom encountered a hole, it would hook the thread underneath it. If it didn't encounter a hole, the hook would thread into it. Eventually, this spun up a design pattern on the fabric. These cards were known as punch cards. And while Mr. Picard reinvented the textile industry, he probably didn't realize that his invention would shape the world of computing and the world itself today. Pretty epic, Mr. Picard. Pretty epic. Let's fast forward a few decades and meet a man by the name of Charles Babbage. Babbage was a gifted engineer who developed a series of machines that are now known as the greatest breakthrough on our way to the modern computer. He built what's called a difference engine. It was a very sophisticated version of some of the mechanical calculators we were just talking about. It could perform fairly complicated mathematical operations, but not much else. Babbage's follow-up to the difference engine was a machine called the analytical engine. He was inspired by Picard's use of punch cards to automatically perform calculations instead of manually entering them by hand. Babbage used punch cards in his analytical engine to allow people to predefine the series of calculations they wanted to perform. As impressive as his achievement was, the analytical engine was still just a very advanced mechanical calculator. It took the powerful insights of a mathematician named Ada Lovelace. To realize the true potential of the analytical engine. She was the first person to recognize that the machine could be used for more than pure calculations. She developed the first algorithm for the engine. It was the very first example of computer programming. An algorithm is just a series of steps that solve specific problems. Because of Lovelace's discovery that algorithms could be programmed into the analytical engine, it became the very first general-purpose computing machine in a great example that women have had some of the most valuable minds in technology since the 1800s. Welcome back. In this video, we'll be learning how huge devices like the analytical engine shrunk into the computing devices that we use today. The development of computing has been steadily growing since the invention of the analytical engine, but didn't make a huge leap forward until World War II. Back then, research into computing was super expensive, electronic components were large, and needed lots of them to keep anything of value. This also meant that computers took up a ton of space, and many efforts were underfunded and unable to make headway. When war broke out, governments started pouring money and resources into computing research. They wanted to help develop technologies that would give them advantages over other countries. Lots of efforts were spun up, and advancements were made in fields like cryptography. Cryptography is the art of writing and solving codes. During the war, computers were used to process secret messages from enemies faster than a human could ever hope to do. Today, the role cryptography plays in secure communication is a critical part of computer security, which you'll learn more about in a later course. For now, let's look at how computers started to make a dramatic impact on society. After the war, companies like IBM, Hewlett-Packard, and others were advancing their technologies into the academic, business, and government realms. Lots of technological advancements in computing were made in the 20th century, thanks to direct interest from governments, scientists, and companies left over from World War II. These organizations invented new methods to store data in computers, which fueled the growth of computational power. Consider this: until the 1950s, punch cards were a popular way to store data. Operators would have decks of ordered punch cards that were used for data processing. If they dropped the deck by accident and the cards got out of order, it was almost impossible to get them stored again. There were obviously some limitations to punch cards, but thanks to new technological innovations like magnetic tape and its counterparts, people began to store more data on more reliable media. Magnetic tape worked by magnetizing data onto a tape. This left stacks and stacks of punch cards to collect dust, while their new magnetic tape counterparts began to revolutionize the industry. I wasn't joking when I said early computers took a lot of space. They had huge machines to read data and racks of vacuum tubes that helped move that data. Vacuum tubes controlled the electricity voltages in all sorts of electronic equipment like televisions and radios, but these specific vacuum tubes were bulky and broke all the time. Imagine what the work of an IT support specialist was like in those early days of computing. The job description might have included crawling around inside huge machines filled with dust and creepy crawling things, or replacing vacuum tubes and swapping out those punch cards. In those days, doing some debugging might have taken on a more literal meaning. Renowned computer scientist Admiral Grace Hopper had a favorite story involving some engineers working on the Harvard Mark II computer. They were trying to figure out the source of the problems in our computer. After doing some investigating, they discovered the source of the trouble was a moth, a literal bug in the computer. The ENIAC was one of the earliest forms of general-purpose computers. It was a wall-to-wall convolution of massive electronic components and wires. It had 17,000 vacuum tubes and took up about 1,800 square feet of floor space. Imagine if you had to work with that scale of equipment today. I wouldn't want to share an office with 1,800 square feet of machinery. Eventually, the industry started using transistors to control electricity voltages. This is now a fundamental component of all electronic devices. Transistors perform almost the same functions as vacuum tubes, but they are more compact and more efficient. You can easily have billions of transistors in a small computer chip today. Throughout the decades, more and more advances were made. The very first compiler was invented by Admiral Grace Hopper. Compilers made it possible to translate human language via a programming language into machine code. The big takeaway is that this advancement was a huge milestone in computing that led to where we are today. Now, learning programming languages is accessible to almost anyone anywhere. You no longer have to learn how to write machine code in ones and zeros. Eventually, the industry gave way to the first hard disk drives and microprocessors. Then, programming language started becoming the predominant way for engineers to develop computer software. Computers were getting smaller and smaller, thanks to advancements in electronic components. Instead of filling up entire rooms like ENIAC, they were getting small enough to fit on tabletops. The Xerox Alto was the first computer that resembled the computers we're familiar with now. It was also the first computer to implement a graphical user interface that used icons, a mouse, and a window. Some of you may remember that the sheer size and cost of historical computers made it almost impossible for an average family to own one. Instead, they were usually found in military and university research facilities. Companies like Xerox started building machines at a relatively affordable price and at a smaller form factor. The consumer age of computing began. Then in the 1970s, a young engineer named Steve Wozniak invented the Apple I, a single-board computer meant for hobbyists. With his friend Steve Jobs, they created a company called Apple Computer. Their follow-up to the Apple I, the Apple II, was ready for the average consumer to use. The Apple II was a phenomenal success, selling for nearly 2 decades and giving a new generation of people access to personal computers. For the first time, computers became affordable for the middle class and helped bring computing technology into both the home and office. In the 1980s, IBM introduced its personal computer. It was released with a primitive version of an operating system called MS-DOS, or Microsoft Disk Operating System. Side note, modern operating systems don't just have text anymore. They have beautiful icons, words, and images like what we see on our smartphones. It's incredible how far we've come from the first operating system to the operating systems we use today. Back to IBM's PC. It was widely adopted and made more accessible to consumers thanks to a partnership with Microsoft. Microsoft, founded by Bill Gates, eventually created Microsoft Windows. For decades, it was the preferred operating system in the workplace and dominated the computing industry because it could be run on any compatible hardware. The more computers in the workplace, the dependence on IT rose, and so did the demand for skilled workers who could support that technology. Not only were personal computers entering the household for the first time, but a new type of computing was emerging: video games. During the 1970s and 80s, coin-operated entertainment machines called arcades became more and more popular. A company called Atari developed one of the first coin-operated arcade games in 1972 called Pong. Pong was such a sensation that people were standing in lines at bars and rec centers for hours at a time to play. Entertainment computers like Pong launched the video game era. Eventually, Atari went on to launch the Video Computer System, which helped bring personal video consoles into the home. Video games have contributed to the evolution of computers in a very real way. Tell that to the next person who dismisses them as a toy. Video games showed people that computers didn't always have to be all work and no play. They were a great source of entertainment too. This was an important milestone for the computing industry, since at that time, computers were primarily used in workplace or at research institutions. With huge players in the market like Apple, Macintosh, and Microsoft Windows taking over the operating system space, a programmer by the name of Richard Stallman started developing a free Unix-like operating system. Unix was an operating system developed by Ken Thompson and Dennis Ritchie, but it wasn't cheap and wasn't available to everyone. Stallman created an OS that he called GNU. It was meant to be free to use with similar functionality to Unix. Unlike Windows or Macintosh, GNU wasn't owned by a single company. Its code was open source, which meant that anyone could modify and share. GNU didn't evolve into a full operating system, but it set a foundation for the formation of one of the largest open source operating systems, Linux, which was created by Linus Torvalds. We'll get into the technical details of Linux later in this course. We just know that it's a major player in today's operating systems. IT support specialist, it is very likely that you'll work with an open source software. You might already be using one like the Internet Browser or Mozilla Firefox. By the early 90s, computers started getting even smaller. Then a real game changer made its way into the scene, PDAs, or Personal Digital Assistants, which allows computing to go mobile. These mobile devices included portable media players, word processors, email clients, internet browsers, and more, all in one handy handheld device. In the late 1990s, Nokia introduced the PDA with mobile phone functionality. This ignited an industry of pocketable computers, or as we know today, smartphones. In mere decades, we went from having computers that weighed tons and took up entire rooms to having powerful computers that fit in our pockets. It's almost unbelievable. And it's just the beginning. If you're stepping into the IT industry, it's essential that you understand how to support the growing need of this ever-changing technology. Computer support 50 years ago consisted of changing vacuum tubes and stacking punch cards, things that no longer exist in today's IT world. While computers evolved in both complexity and prevalence, so did knowledge required to support and maintain them. In 10 years, IT support could require working through virtual reality lenses. We never know. Who knows what the future holds? But right now, it is an exciting time to be at the forefront of this industry. Now that we've run down where computers came from and how they've evolved over the decades, let's get a better grasp on how computers actually work.